download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about cells and batteries. Now in a cell, chemicals react to produce electricity. Now a cell, if we were to draw one out here, contains two electrodes. Okay, so I'm going to draw those here. This is electrode 1 and this is an electrode 2. And these are both in contact with an electrolyte. And I'm going to draw that here. So that's the electrolyte. And here are the electrodes. Now it's important of course that these electrodes can conduct electricity and are able to conduct electricity, and therefore it's usually a metal. So electrodes are usually a metal. And again, the electrolyte also needs to be able to conduct electricity. As you can see here, it's a liquid. So it must be a liquid that can conduct electricity. It needs to contain ions which react with the electrodes. Now what happens is there is a chemical reaction between these electrodes and the electrolyte, and it's important that these electrodes are connected to each other by a wire. So these chemical reactions between the electrodes set up a charge difference between the electrodes. So one of them is going to be more positive and one of them is going to be more negative. There is a difference in charge. And if these electrodes are connected by a wire, then what that charge means, and that charge is then able to flow and electricity is produced. Okay, so the charge difference between this electrode and this electrode causes the charge to flow through the wire, which produces electricity. Now, as ever, you can also attach a voltmeter to this cell where you can measure the voltage of the cell. Now you need to know that different factors affect the voltage of the cell, and you need to learn these different factors, and the first is the identity of the electrodes. Okay, so if again we draw what we drew in the last page, and we've got two electrodes which are connected to each other by a wire and of course are in contact with an electrolyte, the greater the difference in reactivity between these two electrodes, the greater the voltage. So for example, let's have one electrode here, and this is made up of copper. Now copper is not very reactive at all. And this electrode here is made up of zinc. Now zinc is very reactive. Now the difference between them in terms of reactivity is very big. Okay, because copper is not very reactive and zinc is very reactive. So there is going to be a big voltage in this cell. The cell is going to have a great voltage, a big voltage, a bigger voltage. Whereas let's draw another example, and again we've got our well-drawn electrolytes connected, electrodes connected with a wire in contact with an electrolyte. And again we're going to have copper, which is not reactive. And then we're also going to have tin, which is also not very reactive. Now the difference in reactivity here is not as great as the difference in reactivity here. These two differ much more than these two. So what that means is the voltage is actually going to be smaller. It's going to have a smaller voltage. So the greater the difference in reactivity, the larger the voltage. And the smaller the difference in reactivity, the smaller the voltage. Now you may also be asked to work backwards on that, so where you're given the voltage and you're actually then asked to apply that to see which one is more or less reactive. Okay, so if we go, remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Go back to that previous slide, we learnt that the bigger the difference in the reactivity, the bigger the voltage. So if we apply that same logic the same way, that means the bigger the voltage, the bigger the difference in reactivity. So here you might get given a table that looks like this with all the voltages, and you may be asked to order them in terms of their reactivity. So of course we know that copper is not very reactive, so that's going to be at the bottom. But then we can look at the voltages. So the next smallest voltage is actually tin. So we know that the next one is going to be tin. And then if we look it up, it's iron at 0.78 is the next smallest. So it's going to be iron. And then it's zinc with 1.1. And then the biggest voltage is magnesium. Okay, so the biggest voltage here is magnesium. So that tells you that must be the most reactive. So you can see here the most reactive one is given the biggest voltage. Okay, so here we've got the most reactive, and here we've got the least reactive. Okay, so you may be asked in an exam to order the metals based on their reactivity when you've been given the voltages of the cells with the two electrodes. Okay, so just remember that the bigger the voltage, the more reactive, and the smaller the voltage, the less reactive. So as we just said in the previous slide, one factor that affects the voltage is the electrode and the difference in reactivity between the two electrodes. Now another factor that affects the voltage is actually the electrolyte. Okay, now you'll remember that the electrolyte is that liquid that the electrodes are in contact with. Okay, now this liquid must contain ions and it must be able to conduct electricity. Okay, now the lower the concentration of the ions, the lower the voltage would be. And just in the same way, the higher the concentration of ions, the higher the voltage will be. Okay, so again, I'm going to draw two examples here with two electrodes. And here are the ions. I'm going to draw them in this one. So we see positive and negative ions, and here are the ions in this one. Okay, now in terms of concentration, a higher concentration is going to be more of them in a smaller volume. So you can see here, this is a higher concentration of ions because there's more of them. And therefore this here is a lower concentration of ions. Okay, now if we apply that logic to what we just said, the higher the concentration of ions, the greater the voltage. So this one here is going to have a larger voltage, and this one here is going to have a smaller voltage. Okay, so the higher the concentration of ions, like in this picture here, the larger the voltage. Whereas the lower concentration of ions, the smaller the voltage. Okay, so the bigger difference in reactivity, the larger the voltage, and the higher concentration of ions, the larger the voltage. And you need to be able to remember both of those. Now, a battery is just two or more cells that are joined together in series. Okay, so we can form a battery by connecting two or more cells together in a series. So again, here we're going to draw one cell where we have an electrode here, an electrode here, and then the electrolyte. Okay, then we're going to draw another cell, and again an electrode, and an electrolyte, and finally we're going to draw another cell with an electrode, and electrolyte. Now we can make this into a battery by connecting these cells together in a series. Okay, as you can see I'm doing there. We're connecting the cells together in a series so that current can flow through them all. Okay, so it can go, if we start here, it can flow through the wire, and it can flow in through the electrode, into the electrolyte, through. So we can see here we've got that current that can flow in series through the battery. Okay, so the battery is formed by connecting two or more cells together in series. Now the voltage of this battery is greater than any of the individual voltages, and in fact the voltage is actually equal to all the voltages added together. So for example, if we take the cells here and each of these cells has a voltage of 5 volts, then when we connect them all together, the battery will have a voltage of 15 volts because we've done 5 and 5 and 5. So we've just added them together. Okay, so if we were to change that and actually these, maybe we change the electrode, and actually now each cell is 10 volts, then we connected them together, the battery would be 30 volts, okay, because it's 10 add 10 add 10. Okay, so the voltage of the battery is just the voltage of the individual cells all added together. So that's quite nice to learn. Now, as you probably know from real life, there are different types of batteries. You can get non-rechargeable batteries and cells, or rechargeable. Okay, now in non-rechargeable cells and batteries, they stop working once the reactants are used up. Okay, so when we're talking about the reactants here, we're talking about the ions within the electrodes or within the electrolyte. Okay, so again, if we're drawing our electrode and our electrolyte, these are going to contain ions, and once they are used up, once they are all gone, the cell is no longer producing electricity. Okay, and therefore it stopped working. The cell and battery have stopped working. So all the ions get used up and turned into products. Once this has happened, the reaction can't happen. So no electricity is produced. Now these products that are formed from the ions cannot be turned back into the reactants. So they can't be charged. Okay, so the products that are formed cannot be turned back into the ions, and therefore we cannot recharge the cell. Whereas reactions in rechargeable cells can be reversed by an external electric current, and that means that they are rechargeable. And when the reactants, i.e. the products, have been reversed back into ions, those ions can then be used again to produce electricity, and therefore the batteries can be reused once they have been recharged. Okay, so the important difference between non-rechargeable and rechargeable batteries is that non-rechargeable, the reactions cannot be reversed. So the ions cannot be turned back into ions. So once they're used up, the battery no longer works. Whereas in rechargeable batteries, the reaction can be reversed, and therefore they can be turned back into ions, which can then produce electricity again, and they can be reused. Okay, so reactions in rechargeable cells can be reversed by an external electric current, i.e. recharged. Now, alkaline batteries are examples that you'd put in a torch, for example, are made up of cells which use irreversible reactions, and i.e. they are not rechargeable. So those batteries you buy, they are non-rechargeable, and once the reactants are all used up in those batteries, they don't produce the charge anymore, so you have to replace them. You have to buy new batteries. Okay, unless you buy the rechargeable ones, where the reaction can be reversed, and then you can reuse those batteries. So here are some summary questions to really check your understanding of this topic. So pause the video to have a go. Okay, let's run through these answers then. So question 1, what is a cell? Well, we can define it really as a system that contains chemicals which react to produce electricity. So for example, you've got the electrodes and the electrolytes which react to produce electricity. Well then, what is a battery? Well, a battery is 2 or more cells connected together, and the important thing here, in a series. Let's take 2 factors that affect the voltage of the cell. Well, you have the reactivity difference between the electrodes, so of course the electrodes you use, i.e. the reactivity difference between them, and also the concentration of ions in the electrolyte. Okay, so the concentration of ions within the electrolyte. Question 4, the bigger the difference in the reactivity of electrodes, the what? Well, we're going to say the greater the voltage. So the larger that difference in reactivity, the greater the voltage. For 5, how do you work out the total voltage of a battery? So all you have to do really is add up the voltages of each cell. So if you have 3 cells, all 2 volts, connect them together in a battery, 2 plus 2 plus 2 is 6 volts. When do non-rechargeable batteries stop working? Once the reactants have been used up. Okay, so once the reactants have been used up, the battery stops working. And finally, how does a rechargeable battery work? Well, the reactants are recharged by, let's write this down, so the reactants and the products that are formed are recharged by reversing the reaction. And question 7, how does a rechargeable battery work? Well, in a rechargeable battery, the reaction can be reversed by connecting it to some sort of external electric current. So the reaction can be reversed, so the products become the reactants again, and they can be used, those ions can be used to produce electricity. So the reaction can be reversed. So we've now looked at cells and batteries. There are plenty more practice questions on the website. And as ever, if there's anything you didn't quite understand, please do get into contact with one of our tutors who will happily help.